Estimate population mean when population standard deviation is unknown. Population standard deviation unknown. If the population standard deviation, sigma, is unknown, then the mean has a student's t-distribution, and the sample standard deviation is used instead of the population standard deviation. The maximum error of the estimate is given by the formula for E shown. The T here is the t-score obtained from the student's t-table. The t-score is a factor of the level of confidence and the sample size. As shown below, the formula is E equals T S over square root of n. Once you have computed E, I suggest you save it to the memory on your calculator. The reason for this is that the limits for the confidence interval are now found by subtracting and adding the maximum error of the estimate from/to the sample mean. Notice the formula above is the same as for a population mean when the population standard deviation is known. The only thing that has changed is the formula for the maximum error of the estimate. Student's t-distribution. When the population standard deviation is unknown, the mean has a student's t-distribution. The student's t-distribution was created by William T. Gozet, an Irish brewery worker. The brewery wouldn't allow him to publish his own work under his name, so he used the name student. The student's t-distribution is very similar to the standard normal distribution. It has symmetric about its mean. It has a mean of 0, a standard deviation and variance greater than 1. There are many t-distributions, one for each degree of freedom. As the sample sizes increases, the t-distribution approaches the normal distribution. It is a bell-shaped, and the t-scores can be negative or positive, but the probabilities are always positive. Degrees of freedom. A degree of freedom occurs for every data value which is allowed to vary once a statistic has been fixed. For a single mean, there are n-1 degrees of freedom. This value will change depending on the statistic being used. When the population standard deviation is unknown, the sample standard deviation is used to estimate in the confidence interval formula. You can calculate a confidence interval for the mean or average of a population even if the standard deviation is unknown or the sample size is small. When a statistical characteristic that's being measured, for example, income, IQ, price, height, quantity, or weight is numerical, most people want to estimate the mean value for the population. Some notations are U equals population mean, X equals sample mean, S equals sample standard deviation, N equals the sample size, E equals margin of error, and T equals critical value. And requirements are it must be a simple random sample and conditions have to be satisfied. Population normally distributed and N greater than 30. For example, suppose you work for the Department of Natural Resources and you want to estimate with 95% confidence the mean length of all the walleye fingerlings in a fish hatchery pond. You take a random sample of 10 fingerlings and determine that the average length is 7.5 inches and the sample standard deviation is 2.3 inches. Number 1. Because you want a 95% confidence interval, You have to determine your t-value as follows. The t-value comes from a t-distribution with 10 minus 1 equals 9 degrees of freedom. This t-value is found by looking at the t-table. If you look in the last row where the confidence levels are located and find confidence level of 95%, this marks the column you will need. Then, finding the row corresponding to df equals 9, you will then intersect the row and column and you will find t equals 2.262. This is the t-value for a 95% confidence interval for the mean with a sample size of 10. 2. You know that the average length is 7.5 inches. The sample standard deviation is 2.3 inches, and the sample size is 10. This means x is 7.5, s is 2.3, and n equals 10. Number 3. Multiply 2.262 times 2.3 divided by the square root of 10. The margin of error is therefore the formula below. Number 4. Your 95% confidence interval for the mean length of the walleye fingerlings in this fish hatchery pond is 5.86 to 9.15 inches. Notice this confidence interval is wider than it would be for a large sample size. In addition to having a larger critical value, the smaller sample size increases the margin of error because n is in its denominator. With a smaller sample size, you don't have as much information to guess at the population mean. Hence, keeping with 95% confidence, you need a wider interval than you would have needed with a larger sample size in order to be 95% confident then that the population mean falls in your interval. After you calculate a confidence interval, make sure you always interpret it in the words of a non-statistician would understand. That is, talk about the results in terms of what the person in the problem is trying to find out. Statisticians call this interpreting the results in the context of the problem. In this example, you can say, with 95% confidence, the average length of walleye fingerlings in this entire fish hatchery pond is between 5.86 and 9.15 inches, based on my sample data.